Right, so moving on to 7.2, PO2. Last lesson, we've learned about the compound angle formulae, which is 6 of them, but you can simplify into 3. Sine A plus and minus B, sine A cos B plus and minus sine B cos A, and cos A minus B is cos A cos B minus plus sine A sine B. And tan A plus and minus B, 2 version. This one is the least one that we use, tan A plus minus tan B over 1 minus tan A tan B, or sine over cos, right? So you've learned 6 formulae. Right, so today's lesson is about using them in a different ways. Okay, there are many ways we can use a formula, right? The one way to use it is to find exact values of trig functions, different angles. Now, hopefully in GCSE, you would remember something like the special angles 30 degree, 45, 6 degree of sine, cos, and tan, right? Sine 30 degree is a half, and cos 60 will be a half. 45 will be, actually, if we put them all over 2, I'm not sure if you've learned this method. On the numerators, 1, 2, 3, for cos is 3, 2, 1, and then put a square root on them. Okay. Now, so using these trig values, actually 10 will be root 3 over 3, and then 1, and then root 3. So using these values, we can actually make different angles out of it, because we can also find the special angles of 15 degree, for example, 45 and 30 makes it 15, for example. Okay, so e.g., use a suitable angle formulae. Show that sine 15 degree equals root 6 minus root 2 over 4. So sine 15, as I've just said. Now I know sine 15 degree is the same as 45 degree minus 30 degree. So sine A minus B equal sine A cos B minus sine B cos A. So yeah, so the reason we do that is we want to use these values is because we do know the exact value of individual terms, right? Sine 45 is root 2 over 2. Cos 30 is root 3 over 2. Sine 30 is a half. Cos 45 is root 2 over 2. So if I simplify, the first term is root 6 over 2. Second term is root 2. So you can see over 4, I mean, and that's it. Yeah. Now, let me give you one question, extra question to try. Can you try to do the same with cos 75 degree? Actually, cos, yeah. Can you do the same with cos 75 degree? Try to do the same. Okay, extra question. Can you work with the exact value for cos 75 degree using these special angles? Okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. Cos 75 degree equals cos 45 plus 30 equals cos A cos B minus sine A sine B, and then you get the same answer, right? Which is the same as sine 15. We know that works because remember, if you want to change the sine degree into cos counterpart, it's 90 minus the angle. So sine 15, 90 minus 15 is 75. So that's why they're the same. Okay, I think we've mentioned that. 30 plus 60 is the same as 90. Therefore, sine 30 is always cos 60. And cos 30 is the same as sine 60, that kind of stuff. Right? And sine 20 will equal to cos 70. Yeah, so sine 20 cos 70, sine 30 cos 60, sine 10 cos 80, right? So next part, how we can use the compound angle formula is to work out the different values of cos A minus B given the special values of sine and cos. Right, given that sine A equals minus 3/5 and A is between 180 degree to 270 degree, and that cos B equals negative 12 over 13, and B is obtuse. Find the value of cos A minus B. Well, question A, first of all, question A. Now, before we do anything, what we can do is, we know sine A equals minus 3/5. If we ignore the negative sign, okay, or actually, let me think of this a different way. Yeah, actually, yeah, so if I draw a triangle out for triangle A, okay, triangle A, so sine A, if that angle is A, what we know is angle is 3/5. Okay, and then triangle B, or cos B being 12/13 is here. Yeah, would you agree? Because 3/5 opposite over hypotenuse for sine, and for cos B, adjacent over hypotenuse. Now, obviously, we do need to take negative into account, but probably not yet. Actually, let me move this across. Now, from here, what we can do is we can write down the values of cos and sine. So what's cos A? Cos A will be, if I work out the 3, that will be 3/4/5, so it'll be 4/5. Now, question is, the sine does come into play. We know A is between 180 degree and 270 degree. In a cast diagram, between 180 to 270 is here. This part is when tan is positive. So therefore, cos A will be negative. So I want to write down, okay, cos is negative because A is in third quadrant. Now, if you don't remember which quadrant is it, you can draw this little cast diagram thing in here. Okay. And then what we also know is the value of tan theta, tan A. Tan A equals to 3/4. It's going to be positive because third quadrant means CAST, T is positive. Yeah, tan is positive. Okay, let's try same with B. Right, this time B, which quadrant is it in? B is obtuse. Obtuse means between 90 to 180. That means here. So CAST. Okay. Does it not look like a sun drawn by a kid or by me? Anyway, it looks like a sun, doesn't it? Anyway, right. Using trigonometry Pythagoras, we can work out this value here is 5. Now, there's quite another famous Pythagorean triplet. So 3, 4, 5, everyone, this is the most well-known Pythagorean triplet. That means the 3 numbers that work with the Pythagoras triangle. So 3, 4, 5 is 1, is outside knowledge. Do you know the other one? I'll give you one. 5, 12, and 13. Anyone else know another? 7, 6, 6, 8, 10, and 7, 24, 25. These are probably the most well-known ones. And there's actually a study to how to work them all out in university, but it'll be, that's outside knowledge. Anyway, right. So in here, what we can work out is the value of 10 sine B and tan B. Sine B is 5/13, opposite over hypotenuse. But because B is obtuse, so in the sine quadrant, so sine is positive. Now, if you do need to write down the reason why sine is positive, you write down. Okay, I'm not going through it. Okay, very similar to this one. What about tan B? Tan B is 5/13, 5/12, opposite over adjacent. It'll be negative. It's negative because B is in the second quadrant. Only sine is positive. Do pause the video and write down notes if you need to. Okay. So now after we have all the values, sine A, cos A, tan A, sine B, cos B, tan B, we can now expand all the formula and work out the answer. So question A, cos A minus B. Cos A minus B using formula is cos A, cos B, plus sine A, sine B. If you haven't remember what the formulae are, go home now, go home, so maybe you're home, and remember them, okay? Maybe stick it on the ceiling as well. I know you probably have some, I've asked you to put some equation in the ceiling already. But if you haven't, yeah, try to stick more formulae on the ceiling. So yeah, if there's a water leak from the ceiling, stick in the formula. Hopefully it will stop them leaking. So cos A, cos B. Cos A is minus 4/5, so negative 4/5. Cos B is, given by the question, negative 12/13. Sine A is, given by the question, minus 3/5. And sine B, we found it, is 5/13. So therefore, just plug the whole thing in calculator in the fraction, let the calculator do the hard work, and you should get 33/65, which is the answer. And now, some of you may be asking, oh, sir, why do we do it all that way? Can we not just find the arc sine and work out the angle A? Yes, but that's not the point of this lesson. The point of this lesson is to show you how we can use this exact value, use the compound angle formulae to work out the answer without finding out what the value of A is. Okay. Right. Part B, 10A plus B. So part B, 10A plus B. So pause video, write down the formula. What's the 10A plus B? 10A plus 10B over 1 minus 10A, 10B. Now, you know the values of 10A, 10B. So I would suggest you can pause the video and work out the answer. Okay, when you're ready for the answer, you can press play. That's the answer, 16/63. Okay, so here's the working out. Now for part C, pause the video, have a go at the question, cosec A minus B. Okay, cosec is 1/sine. So pause the video, have a go at the question. Okay, when you're ready for your answer, you can press play. Here's the answer. So 1/sine A minus B. So I can use the formula sine A cos B and minus sine B cos A in the denominator. Then sine A is minus 3/5. So you just put in the values accordingly. You should get 65/56. If you haven't, there should be some silly mistakes. All right. Next one, here's a challenging question, which requires you to know the knowledge about how to change sine into cos. Remember what I said, sine 30 will be the same as cos 60, or sine 10 will equal to cos 80 because they add up to 90 degrees. So that kind of concept. So question A, have a go, okay? And question B as well, if you struggle with question A, you can. So pause the video first, have a go at the question A, okay? If you're confident enough, have a go at B as well. When you're ready for the answer, you can press play. So pause the video, have a go. When you're ready, press play. Right, here's the answer. Okay, so I want to show the whole formula. The question wants me to transform this formula equation to cos x plus 50 equals sine x plus 40 into this. So how do we change caterpillar into a butterfly? Let's have a look. First step, what I did was, I see sine A plus B, cos A plus B, and sine A plus B. What did I do? Expand the bracket, use a formula. So you can see I color coded with the yellow. Cos A plus B, cos A cos B, minus sine A sine B. On the right side, sine A cos B plus sine B cos A. Next, I look at the question. There was no 50 degree in there at all. So I did a clever trick into making cos into sine, because 50 degree plus 40 is 90 degree, and it's not a coincidence. That's why it's 50 and 40. So I changed cos 50 degree, which I know cos 50 is same as sine 40 because they add to 90 degree. So change this cos 50 into sine 40 and change this sine 50 into cos 40. Again, why 50 to 40 but not 40 to 50? Because the question is only requires 40 degree. So they don't want to say 50 degree. Okay, they hate 50 degree. They want to get rid of 50 degree. Okay, so that's what we do. Okay, I didn't change anything else apart from these two, cos 50 and sine 50 into sine 40 and cos 40. Next, I did a very simple step, just an intermediate step, expand the bracket. Now, one thing students do is they're too lazy to write down steps in between. Even though it's a silly one like expand the bracket, just write it down, because then you can process one thing less for the next step. Next, what you will see is actually there are two pairs of like terms. The first pair is 2 cos x sine 40. So cos x sine 40, you can see cos x sine 40, there's another one in there on the right hand side. So then what I did was bring them to the left hand side. Another one is the minus 2 sine x cos 40 and sine x cos 40. So I bring this to the right hand side, makes it a plus. Next, I then combine the like terms. 2 lots of things minus 1 lot of is just 1 lot. 1 lot plus 2 lot is 3 lots. Right? Next, then time to make it into 10. So what I did was I divide both sides by cos 40 degree. So sine 40 over cos 40 makes a tan 40. And then, so that's what I did. Next, I divide cos x over the right side. So so tan 40 equals 3 tan x. Next, they want tan x to be subject, so I divide the 3 over, and I just swap the left and right side. Okay. If you're happy with this, then try question B. Pause the video. Have a go at question B. When you're ready for the answer, you can press play. Where's part B? That's part B. Okay. Use the answer in part A and have a go in part B. So here's the answer for part B. Well, first thing I realized is, when you see the word hence, means you want to use the previous answer. That's what that word hence means, exam technique for you. You look for the similarity. Similarity is they look very similar, apart from the fact that x becomes 2 theta. So what I realize x equals 2 theta, write down. So the question A wants us to transform this caterpillar into this butterfly. So we can rewrite the whole equation into the butterfly equation, which is a tan rather than x with 2 theta. So tan 2 theta equals a third tan 40. Because the right hand side has nothing to do with x, we just rewrite the whole thing, 40. Next, I inverse tan arc tan the right hand side. So it looks a messy one, but just put in calculate. Let's calculate the dirty work, and you get 2 theta equals 15.6 degree. Cast diagram for tan to be positive is that one is there as well. So 195.6. But 2 theta means the domain is now widening twice. So times by 2, that means we have to add 360 to find another pair of answers, and then divide by 2. These are the final answers. Okay. That's why it's a challenging question. Right? The whole question is quite challenging, especially the first part about proof. Right? So yeah, that's the end of 7.2 about how we use double angle formulae. Compound angle formula is one, we can find a special angle, find some exact values of different angles that we haven't learned in before, like 15 degree, using combination of these. And then we've also learned how to find the value of cos A minus B without working out the exact value of A and B. Right? And yeah, that's it.